So I had this idea for the talk because somebody in the forum said something I disagreed with, and then I realized I have a bunch of pet peeves. So I'm just going to rant for a bit and tell you what you're doing wrong. So these are my opinions, so they're not facts. And whenever I say do this, don't do that, basically mentally preface it with, in my opinion. But that's boring, and also it's a lot of typing, so I'm not going to do it. And so I'm telling you right now. Now, my PhD supervisor told me ages ago that an expert is somebody who's made every mistake possible. Now, I'm not calling myself an expert, but the thing is that my opinions are here for a reason. I banged my head against the wall, and now I'm trying to prevent you from banging your head against the wall. And rule number 0, for me anyway, for programming is always use your head. That's why we pay the big bucks. Think about things, understand what the trade-offs are, and make a decision. So don't cargo cult any of this either. They're just guidelines. Always actually think about your situation. Does it apply or not? And of course, it's more than okay to disagree with me. Sometimes I'm an idiot. And to frame as well the guiding principle of all this is that refactoring for me is key. Nothing you do in a 200-line script that you wrote yourself and nobody else is going to see matters. It doesn't matter. You can use global variables. You can use go-tos. It doesn't matter, because all of the engineering principles that we hear about is when you have thousands of lines of code and there's multiple people working that code base. Now things start to matter because it just doesn't scale otherwise. So refactoring is key because you're going to have to change your code. If you're not changing your code is dead, nobody's using it, it's useless, which means, of course, nothing matters at that point either, because a project that doesn't have people finding bugs on it isn't being used. It just isn't. It can't. Even if you wrote the most perfect thing ever, your users could be idiots and don't understand what it's supposed to be doing. So one way or the other, you're going to get bugs, so you need to fix them. You need to change things slightly. Situations change, your environment changes, your code needs to change. And when your code needs to change, then we want to make that change to be easy to do, not hard. So everything I'm going to talk about now is because I think, well, not everything, but a lot of these things is refactoring is key. So whatever makes refactoring easier is good. Whatever makes refactoring harder is not. And the moral of the story is that if you take anything away from this talk at all and forget everything else, is that the API is paramount and the implementation is absolutely not. Of course, except when it is, but you'll know, for instance, if it's slow or buggy, that kind of thing. But modulo those things, the implementation doesn't matter. I should be able to completely and utterly change it, and you won't know as long as the program does what it did, i.e., if the test still pass, then you haven't broken anything. You should be more than free to change implementation. The API, however, is what really matters because that's how your users interact with the system. Whether it be a REST API or a command line interface or an actual API that you use for programming, that's what you really care about. Implementations don't matter. So, stop writing classes. And why? Because, well, first of all, no, it's a billion-dollar mistake for a reason. You have this weird value that all the types, also participate in. I don't think I have to talk about the problems of null. Everybody's hitting these problems before, and you get it whether you want to or not. Sure, you can put class on the stack, but that's not usually what you do, and you get null. Null is bad. Don't do it. Reference semantics are terrible. I don't want to be poking something here and then having something come out over there, but that's what you get with reference semantics, and that's what you get with classes. And why would we have that? It makes sense, because when you have runtime polymorphism, you don't know the types that you actually have at that time, which means you don't know their sizes, so what can you do otherwise? You pass a pointer. But this is what you get baked in whether you want to or not. That's not a good idea. So if I see a class that has no child classes and doesn't derive from anything, why does it exist? I don't know either. Use a struct. It'll be better. And of course, there's an asterisk there because unless you actually need runtime polymorphism, in which case, yeah, write a class, because they don't really have many options otherwise. But don't. And we only use reference semantics anyway when we are trying to avoid copies, because that's why we do const ref and C++ all over the place. It's to avoid doing a copy because copies are expensive. But we don't actually want reference semantics. We want value semantics because that's easier to reason about and you don't get spooky action at a distance. Sean Parent even did a talk in which he was illustrating how he got the best of both worlds by using a shared pointer of const t. That way, you can't really mutate things, so you don't get action at a distance because you can't change it. And what you do is just change where the shared pointer is pointing to, which is fine. But reference semantics as in classes, as in D, not good. And you pay for things you don't need. At work, we have external C++ classes. We're not using them to interface with C++ at all. It's just decode. Why? Because we don't want to monitor. So that's already showing that that wasn't a good idea. And you don't even actually need classes in the language like I've mentioned before, because I wrote a proof of concept showing that with reflection and structs, you can get the same thing. And if you really, really, really want a reference to something, new it, you can pass a pointer to a struct if you really need to for some reason, but don't. Just pass it by value. Unless, of course, you profiled and it's slow, in which case. But at that point, you actually have a reason to not preemptively, oh, I don't want copies. Why not? Does it matter? Probably not. Why is this thing not working? There you go. Right, private. Use private everywhere. Private is good. Private, friends don't let friends write public everywhere because that's a bad idea. I would treat your code implementation definitely like your underwear drawer. Do you want random people there? No, you really don't. So put private everywhere. You don't want random people in your privates. And API design needs to be explicit, not implicit, not something that you have to explicitly say, I want this to be public, I want it to be private. Well, you do, actually. You don't want things that happen to be your API because you happen to write some functions. I see a private function in the module and it's not used anywhere, I delete it because it's useless. If it's public, I can't. Oh, I can grab the rest of the code base. Okay. Unless your code base is useless, as we mentioned before, somebody's using it. How are you going to grab their code bases? Do you want to break things? No, because then you'll get angry users complaining at you. And if your clients can do something, they will. And therefore, you need to support it, whether you want to or not. And you probably didn't. And just like you shouldn't get married to random people you meet off the street, don't get married to all of your users by promising things that you don't want to in the first place. And yeah, so for private functions deleted, does it make a sound? No, just delete all the private functions that you see aren't doing anything. So I think these are the reasons why I think private is a good idea, because, again, I should be free to change the implementation, and if it's not private, I'm not allowed to. Don't test private functions, because why would you? If the behavior you want isn't detectable through your public API, what are you doing? What is the point of the thing you're testing? I'm testing a private function for a reason. If that private function isn't being called by your public API, why does it exist? Don't even write it in the first place. Now, sometimes, especially if you're doing TDD, maybe you're uncomfortable with the fact that you're writing a function without explicit tests for that function, and maybe it's really small and it kind of looks cool. Okay, but in that case, be willing to delete those tests. And for most people, this feels icky. Like, I don't want to delete them. Delete them. Delete the function, delete the test. Deleting code is great. Just, as long as your test pass, and as long as you're not deleting the tests themselves, delete stuff. Red diffs are the best diffs. And think carefully about your dependencies, because I see a lot of code out there that everything imports everything and everything depends on everything. Focus. Don't do that, because it's a bad idea for multiple reasons. It's harder to reason about. It's harder to find where things are defined. It's just harder to find everything and think about it. Cyclic dependencies can be bad for multiple reasons. You can get problems with module constructors, for instance. And one thing that I don't think a lot of people talk about or think about enough is the build system itself and how long it takes to build things. Because if everything depends on everything, when you make a change, everything needs to be rebuilt. And that's probably not what you want. At least for me, I want to rebuild the fewest amount of things possible given any change I've made. And so I think it's a good idea to think when you're writing a function or a type, where does this go? Where should it go? Where should it be visible from? So, what package should it go into? What module should it go into? And an example from DPP that I've got here is that I have a package module called type. And the only reason for its existence is to manage dependencies, because I don't want everything to be rebuilt all the time. So for the people who don't know, DPP does translations of C and C++ headers into D code. And the translations, of course, basically recurse, because if you have a struct, then you go into this members, and then you recurse into that. And so there's translation for things like enums and for macros and for functions. But there's also translation for types, basic types, and things like that. So all of the other translations I just talked about depend on having to translate types, but not the other way around. And so I don't want that package module to be compiled with everybody else, because if I change it, they have to be rebuilt, but not the other way around. And if I hadn't done this and lumped it all together, I would get worse build times for nothing. Now, having said that, the reason why my build times are the way they are is because I build the code per the package. And the reason and how I do that is because I use reg instead of dub normally, and that's the default, and it's a default for a reason, because it tends to be faster, at least in the benchmarks I did way back in the day. And so it's unfortunate that because most people use dub and build all at once, they won't even get the benefits of that anyway, because you change one module, you rebuild all of them. But that's not a good thing, and something that we need to change in dub anyway, so that everybody gets the benefit of that. And I would think of D packages like object-oriented class hierarchies, in the sense that if it's too deep or too wide, then you're probably doing something wrong. So if you only have one D package in your program and there's 20 modules in there, rethink your life decisions. Local imports, or imports that's been in D runtime for a while now, basically to avoid any global imports of any kind. Why? Because again, just like location, it's refactoring, refactoring, refactoring. Because I want to be able to just cut a function up, move it to somewhere else, because again of the dependencies we just talked about. And is this function really supposed to be here? Is this the best place it can be? Because if I'm importing a bunch of stuff from somewhere else, maybe it should be in that module instead. And so I want to be able to move functions and not care, instead of figuring out which imports I need to take with me, which might not be trivial. And because of dependencies, like I mentioned, and somebody could say, as somebody has mentioned in this conference, well, what about tooling? I don't care. Just let the tools do their thing. Well, first of all, I think that language design that depends on tooling is bad language design. And I haven't seen any that work properly yet, but I could be convinced otherwise if I do, and one exists, but I'm not aware of them. But the other thing that tooling won't solve, well, maybe it will, if you do local imports for everything, is that when you have global imports, it hides how bad your function is, in the sense that it has too many dependencies, because you can't tell. Now, if you do have a lot of imports in a module, then your module is definitely doing something wrong, because it shouldn't be having all of these dependencies. But it's a lot easier for me, at least looking at a function that's importing 20 different things, that this is a code smell, and there's something that's really definitely going wrong here. And it's a lot more explicit that way. And again, dependencies are bad for multiple reasons: comprehension, build times, etc. If you're caring about endianess, and you're not writing a compiler backend, and you're not actually encoding something, you're 99.9999999% definitely doing it wrong. You shouldn't care. You definitely shouldn't care. And Átila is laughing because I've already told him that earlier this year or last year, I can't remember. It doesn't matter. CPUs do what they do. If you use the operations that CPUs know how to do, like shifting bits and ANDing and ORing, they do that. That's literally what they're supposed to do. It doesn't matter what things look like in memory. Let the CPU care. Why do you care? When I was younger, I never understood the host and network macros and vice versa, because I don't understand why they exist. There's no point. Just don't cast things. Don't cast pointers. Don't reinterpret them, and you'll be fine. For instance, the code there takes a big endian encoded stream, which is a very different thing from caring about the endianness of your CPU, and takes a 32-bit integer and then decodes it into a 32-bit integer. That's the code that would work on a little endian machine. The code that would work on a big endian machine is exactly the same code. There's no point of making a version this and then doing that is completely useless. It won't work. But then you might say, well, what about performance? If I'm on a big endian machine, I could just cast the pointer and there I go, right? Guess what the compiler does when it sees this? Don't try to outsmart it. It's fine. Also, you profiled, right? That's why you care about this. Because if you didn't profile, why are you caring about this? You're doing it wrong. Walter has a question.
As it turns out, the compiler optimizers recognize expressions like that. And if the endianness matches, it just generates a load.
Yeah, exactly. So stop trying to outsmart things. Also, stop trying to optimize things that probably won't matter anyway. I've literally run a profiler once in my whole entire life, and the bottleneck was where I thought it would be. Every other time, it's like, what? I still remember the function that caused my first bottleneck by name. It was printf. Don't print things. It was the lesson there. Also, mixed endian machines exist. I had to work with one once where the floating point was, I can't remember how, but basically the 64 bits were weird. Like you divided it into two 32-bit portions, and those were swapped for some reason. Don't write auto, because auto is mutable, unless you put a const on the other side, which you probably won't be doing. So don't write auto, write const. Const is good. People keep saying, I can't use const in D. Well, I don't know what you're doing wrong, because I keep doing it all the time and it works. So do const. Also, if not const, probably use scope, because sometimes the inference doesn't work. And that's unfortunate, and that's definitely something we should work on. And the users should not have to care about writing auto scope, but in practice, that's what happens. So use one of those two. But definitely don't write auto to mean I want to write explicitly the types on the left-hand side either, because that's over-constraining. You don't care about the actual types. I know some of you are already feeling something in your gut saying, but I do. No, you don't. No, you don't. Why? Refactoring. Again, you don't care about the actual type. You care about the API. You care about what you can do with that type. That's what you care about. Now, unfortunately, auto under-constrains things, because you don't actually want auto either. Because what would be great is somehow saying, what I want is this, which you can do with classes, of course. You can use an interface instead, and that will be the lowest common denominator, and that way you can change what the implementation is without having to change the declaration. But if you're using templates or something like that, that's different, and we unfortunately don't have a way to express that. What would be really cool is if we could do something like input range of constant, this thing, and then assign. Because then you don't care what actual range is. The type won't matter. The implementation doesn't matter, but this is the API. This is the interface. I want something that behaves like an input range of const integer, which also should be easier to write, because when people say, I can't use const for ranges, the range itself can't be const. But do you care? Because when you use arrays, what you write is, or could write, is an array of const something. And it should be easier for me to say, I take a range, but it should be a range of const something, because I'm not actually going to mutate things. And const is good for code comprehension, et cetera, all those good things. So I don't know how we can get to this promised land here, but that would be amazing.
What do I do if I want to mutate a variable? Do I just jump off a bridge right there? Or?
No. Sometimes the easiest or best code is to mutate. Sometimes algorithms are better expressed that way, and that's fine. What I'm saying is that shouldn't be your default go-to. Like, your muscle memory should be writing const, and then every now and again think, oh, I can't that right now. I'll use auto. I think that unit tests should, by default, again, muscle memory, you should be, in fact, it is mine. I never write naked unit tests. It's always @save pure unit tests, and then if I can't, I'll change it. In fact, I think that, for most tests, they probably should be able to be run at CTFE. Because I don't want to pay the linker price. I don't want to link code. All of that is already boring me just by talking about it. The only thing I care about is running my test as fast as possible. I want a way that optimizes for the time it takes to parse semantic analysis, figure out what I need to do, run the test, give me the feedback I need to know I haven't broken anything, and if I have, oops, I'm an idiot, go back to the last save point. I would love for something like what we saw in Neat, where the compiler is the daemon and is just listening, and I do my changes, and then it just goes, run the test. And only the tests that have changed, because the compiler knows what nodes were affected given the changes I just made. That would be amazing. So I don't want object files. I don't want anything to be written to the disk. All of that is boring. Delivering binaries to customers to me is very, very boring. I don't care. It could take an hour. I'm fine. What I care about is my development workflow. That's the only thing I care about. So, and my tests should be able to, be run fast and also not have side effects, etc. Because if they are like that, it means the API is usable that way, which means the API is probably good, it needs to be tested, and etc. And I write the test first anyway. But of course, this is not always possible, and sometimes it's not even desirable. For instance, if you're writing a translator that takes C code and produces D code, like I have, a really bad test would be to say, given this header, I want you to generate this exact string. This is a terrible test, because if I change the formatting in any way, shape, or form, the test breaks. But I haven't actually broken anything, and that's not a good test. And so the only way you can really figure out if the code you generated is doing the right thing is to compile it. Because what you're trying to do is actually feed something to a decompiler. You have to use a decompiler at some point. And the way I do that is by usually doing a static asserts, because that way I don't actually have to run the compiled code. I just want to assert things about the code I generated, like that the struct is this big, for instance, so the third member is an integer, or things like that. So when you're having to interface with things like that, it's just not possible for you to write, a nice little safe, pure unit test, because you literally just have to interact with it. If you're producing makefiles from a build system, the only way to figure out if your makefiles work the way you think they do is to run make afterwards and make sure that the behavior is what you expect it to be. So it doesn't always work. Point is, this should be your go-to, this is what you should want to do, and then you feel bad for yourself whenever you can't. I also think that test taxonomy is incredibly boring. I don't care what people think is a unit test or integration test or a system test or whatever test. Who cares? I only care about the following things when I write tests. These are the characteristics that I want them to be. Fast, so I get the feedback as quickly as possible. Consistent, so reproducible. They either always fail or always pass for a given commit hash. Flaky tests are bad. Flexible, which I mean by being the opposite of brittle. So the example I gave before about comparing exact strings, don't do that, because it's a brittle test. It breaks for no reason. I want the test to break if and only if I have broken the code, which gets to also the test should capture the actual behavior of the thing that you're testing and not the implementation, because the implementation could change because it doesn't matter. So the worst test I've ever seen in my life was something that mocked the function it was testing and basically line for line asserted that that function was doing exactly the thing it was doing. What is the point? It's a one-for-one representation of this. It will break if you do anything at all to the code, and it doesn't mean anything. And it's not testing anything. I mean, should you be calling this function with these parameters? I don't know. Like, actually verify that you sent a packet with this content, not whatever this thing is. And really try to not write tests dependent on the network. They will be flaky. It's just a matter of time. And if you have one test that has a failure rate of 0.1%, you might not care. Your code base will grow. You'll have 1,000 tests. Oh, look, now you have a test failing every single commit. It's not a good idea. And as an example of I can't write a pure unit test because it won't do, as I was mentioned before with a build system, this is one in Reggae, which produces makefiles. In this case, it's using the makefile backend. And to explain what the code does, I'm using a sandbox. So this environment is one in which I can just create files and not care about where they are, not care about the name of the directory. Just give me one. I just want to write some files to disk and then verify that some things happen. In this case, actually, it's smarter than that because it says Reggae sandbox, and then I'm feeding it a string called dub. That's because there's a directory called dub in the project, and it's reading a dub project for there, and then copying the dub SDL and the source files to the temporary sandbox, because I don't want to dirty things. And then it runs Reggae itself with those command line arguments to produce the makefile. And then that function make just runs make with those command line arguments, because I want to make sure that the compiler flags are the ones I expect. It should execute OK, and it should contain in the output -c-debug because I'm doing a debug build in dub, so that should happen, okay? And then basically what this SS is doing is that if I change the dub selections.json because the dependencies might change, that reggae reruns itself to re-output the new makefile. And so I touch the file that's in the sandbox path, and then I verify that make runs again. If I run make again, it contains reggae in its output because it's rerunning reggae to then recreate the makefile. Why it fails there is something I don't need to get into right now, but I thought it was a good example of showing that, yes, I'm telling you to write pure unit tests, but I also don't because sometimes you can't and you shouldn't want to, and it's okay. Don't write for loops. I mean, I copied this from Sean Parent, but he's right. 99% of them, which is a number I got on the internet that I made up myself, of loops are either map or filter or fold, and I don't want to have to read your code to figure out which one it is. And you might introduce bugs by re-implementing them yourself. Why are you doing that? Don't do it. Use map, filter, and fold. You'll be fine, and so will I when I read it. Yes, sometimes it's a lot easier to express an algorithm as a for loop, so it's like I said before, rule number 0, use your brain, figure out what works best for you in this scenario, but your go-to should be ranges because they're good. And yes, sometimes it's performance issues, but you profiled, right? No? Then why are you worried about it? And parallelism can make this worse too, because can anybody spot the bug there? Because there's a bug. Nobody? Yeah, data race. Now, this is a bug that we need to fix ourselves because basically the lambda that's getting passed to the for each, the context pointer there should be shared so that we can't do that, right? Because I'm appending to the thing, the threads are writing to the same pointer. That's not a good idea. So don't do that. Do you know what works instead? A parallel, map or filter or reduce, whatever you're doing in that case. And the reason I know this is because I wrote this bug and then realized later, and I went, oh, don't do that. I think main should be mostly empty. Nearly every single one of my main functions looks exactly like this. I try to run, real main is called run, and it takes an array of strings just like real main would, the main. Yeah, I don't know what to call them. And then return 0 because everything worked. And if there's an exception, log it, return 1 to the operating system, let the user know that something failed. Now, why? First of all, because I don't want to have a bunch of code that's being lost in a try block that's this big, maybe. Secondly, because it makes testing a lot easier. I used to use Cucumber for behavior-driven development. Given these conditions, when I run my binary with these command line arguments, then this should happen. Because I thought that was the easiest way for me to take my final binary and then test that. For instance, the user got an error message that stated, I can't copy this file because it doesn't exist, for instance. So there would be a test for that. And it's just a lot easier if you can test it with a unit test block, and you just call run instead, because you can't call main from a unit test block, but you can call run. The other reason this is important is because it's trivially simple to make your binary into a library. Don't have this main function. It's called run. Look, it's a library now. Because main is evil. So, I put it in its own file because it deserves to be shunned and ostracized. And also that makes it really easy in Dub to say, just forget this file. I'm a library now. And it's just easy. So I think every binary should be a library because at some point somebody's going to want to use it in a way that you didn't predict, and this just makes it possible. So I think that putting it in its own file makes it even easier as well. There's a question there.
Yeah, I just want to point out, in addition to that, which some people don't realize because you're not paying enough attention, is with Dub in specific, if you do not split everything out of the module with main in it, your unit tests in there will not run because it replaces main to run the unit tests. So one of the issues with Dub then exacerbates this problem such that you definitely don't want to be putting all that code with main.
Right. So there's two issues there. One, that Dub is doing the wrong thing, and two, that so are you because you're not using TDD, because if you were, you would have noticed the tests weren't running.
It's actually even worse because even semantic errors in main won't show up if you run tab test.
So yeah, I think this is a good pattern. I encourage you to use it. I don't know why I would go back to having a main function that's an actual main function instead of this thing, because also it means, I mean, you deal with exceptions is this is how I handle them. Like, what else do? I don't know. So I catch them here. There's no catch blocks basically anywhere else. Or what I care about, especially if it's a binary and it's actually taking command line arguments, is what does the user see? What are the error messages?
I wanted to say I use the same idiom, and it's a templatized on the function itself.
Oh, okay.
My main is a single line, meaning try whatever my function is.
Yeah, that makes sense. I hadn't thought about that. And again, you know, with the error messages that I'm talking about, the tests are trivial to write. What you do is you call run, and then you assert that you threw an exception with the message, whatever it is. Because I don't think people do enough tests for error messages, and they should. Even logging sometimes, because it's like, how do you test the logging? Well, like this. Don't write complicated continuous integration configurations, because if you have a YAML file that's 200 lines long, how do I run that on my machine? There's no way. Unless you can spin up a container that does the exact same thing the CI does, then yeah, sure, knock yourself out. But otherwise, if you can't run things locally and you depend on CI, that's usually a bad idea. There's a bunch of people also depending on same CI. It'll take longer. You can't just run the tests you want. You know, the workflow should be run only the tests you need to run, and then CI will run everything else just in case, you know, your particular mental algorithm for what needs to be rerun right now didn't work. It's more of a fallback thing than anything else. At least that's how I work. But then again, as some of you may know, my pain threshold for getting feedback is about 20 milliseconds. I'm not exaggerating. Anything more than that will make me angry. And you wouldn't like it when I'm angry. I won't turn green, that's fine. Scope exit is intended to make things easy and easier than writing a type with a destructor and using RAII, because sometimes that's overkill. I don't want a new type cluttering things, and also it's over here, and I'm over here, and I can't even see it. Why am I jumping to definition when I don't need to? So the intended usage is, for instance, when you have a C API and you need to set something up in the beginning, and then make sure you shut things down later, you know, you just do the thing, and then scope exit, do the other thing that I need to do to shut things down, and then you never see that again. If you have a bunch of scope exits everywhere doing similar things, write the type. It's a lot cleaner, and you can use with as well to scope the thing, and then you can even have a better API inside of there because you don't need to keep referring to the thing by name. In fact, we saw that in a previous test with a sandbox. That's exactly what it does. Because at the end, it cleans up after itself. And it's easier to write the files and read and do the assertions you need to do. So if you're doing scope exit all over the place, you're doing it wrong, write the type. The intended usage for this. So I don't understand why people like empty parentheses and function calls. It makes no sense to me. I'm lazy. Why would I type the parens? Why? Just why? Oh, I want to make sure it's a function call. Why'd you care? You're reading a value. Maybe it changes over time. Maybe it doesn't. Why'd you care? It's literally what it is at that point. It takes no arguments. It's a value. But it doesn't matter. It's a value. Also, it hurts refactoring, because what if I change it to an actual value? Oh, right, I need to take the parens off. Why are you doing that in the first place? Don't. So I want to be able to write things like an infinite range that has an enum empty equals false, and things work. So don't put parens on it. Why would you? It's extra typing, extra reading. It's 2 more bytes in your file. Who cares? And I saw that in slides, 2 days ago, and I went, ugh. Don't write getters, and absolutely do not write setters.
One thing why you would put parens is that people that are not coming from a deep background, they don't really understand what's happening there. So putting parens clarifies that for them.
I don't think anybody has this problem in Ruby. So I'm not sure that's an actual issue. So getters for me are code smell, and setters are code stink. And the reason why is, why do you want to know? Why do you want to go into the internal state of another object? Instead of asking it for things and then doing decisions, just tell the thing to do it. Do not ask, tell. The whole point of object orientation, as it was initially designed to be, is passing messages. Passing messages doesn't mean you get an answer right now. Just send it a message, go fetch my lunch. Not, oh, what's your menu? No, just do it. Just do it now. So this is a silly example, of course, because it's a slide in the talk. But, oh, I want to know it because I want to print it. No, you don't. Tell the thing to print it. It knows better than you anyway. Why are you reaching in? The whole point is encapsulation. And again, I might change implementation. Maybe I'll do it in a different way. You shouldn't have to know, and you shouldn't break. So, tell, don't ask. Yes, of course, if you go grab right now over my GitHub, have I written getters? Of course. Have I written setters? Of course. But that shouldn't be the default. Look, everything here I've done, and will probably continue doing, because I'll say to myself, oh, it's fine, I know what I'm doing, and every single time I live to regret it. So if you're writing getters, like, oh, this framework makes it really easy to write getters and setters, stop doing that. Don't do it. Don't make it easy. Don't write them at all. Java beans were a bad idea. Don't use shared. Hey, how do you shared in D? The answer is you don't. Use a framework. Use Sebastian's library and do that instead. Have somebody worry about the implementation where shared becomes a thing. Don't use it yourself. Or especially if you have a global variable, don't use gshared either. That's a terrible idea. But if you have a global variable and it does need to be shared among threads, can you make it immutable? Because your problem is solved. So if you're reaching for shared, think twice. Maybe you need to after all, but you probably don't. And if you can make it mutable, your problem is solved. Now, it's true that sometimes making things immutable is a pain. And it's true that sending something to another thread should be allowed if you can guarantee that nobody else has aliases to it, but we don't have a way in the language to do that right now. If we could, then that would also solve the problem, because it's not shared mutable data. It could be mutable if it's not really shared because you sent it somewhere else and I don't have it here. So that's something worth exploring, I think. And the conclusion to this is that, to reiterate what I said in the beginning, the API is paramount. That's what you should care about. It should be simple, should be small, so you have less surface area to test and for people to get things wrong and to write bugs and etc. The implementation is not something you should want to care about unless you have to. Again, if it's slow, you have to make it faster. If it's taking up too much RAM, you need to avoid doing that and avoid allocations and that kind of thing. But it should be the case that if your test pass, you don't really care what's going on under the hood unless you really have to. And if you do have to care, then re-examine your life decisions. And refactoring is key, because code that isn't being changed is dead, and if it's dead, why'd you care about it anyway? Thanks.
So I have a brief question about getters, setters, that kind of stuff. I'm calling some API on the web. There's maybe 40 different parameters I could pass in, but maybe only 2 are required and the rest are optional. How do you propose calling that? Because it sounds like you're saying I can't really make an intermediate object because I don't want getters or setters. So what's the proper way to do this?
Again, maybe the easiest way is to do them, but I would say in this particular case, the builder pattern.
Isn't that built around getters and setters?
Yes, but you're removing the ickiness and putting it over here, if that makes any sense. That's the only reason for its existence anyway. It doesn't do anything else.
All right.
Yeah, going one step further than that, actually, you pretty much don't need setters if you have that in a framework. You shouldn't be setting properties on a variable. You should be replacing it with a new variable that you mutate in a certain way.
That's also a way to do that, sure. And of course, that makes reasoning about your code easier because it doesn't change. If somebody has an alias to the old thing, that doesn't change under the hood. Value semantics.
Yeah, side note, if you're using boilerplate, it does that for you automatically.
You said that we should not use shade if possible. What if I say, OK, I use __ gset instead?
No, don't do that unless you have to because you're interfacing with C or something. Just don't do it. I mean, sometimes, or you're writing a kernel, like we saw a good example of that yesterday. But again, rule number 0, think first. Maybe you need to. Maybe this is the easiest thing. Maybe you got better things to worry about, you know?
In fact, about that kernel thing, that's where I think shared is a good use case. When I did the 8-bit experiments I wrote about in forum, in fact, the exact thing I did, I didn't use gshade. I instead made it shared and cost it away in the functions that really needed the global.
Sure. Again, depends on your use case. Think about it. Guidelines, don't cargo cult things, because that's a bad idea. I worked on a project once that had, so the project was called SLA, and there was a hash defined that was SLA_2, TWO, and it was defined to 2, just in case the number 2 might change, I guess. Because you can tell how this happened, right? Somebody wrote a 2 in the code base, some reviewer went, magic number, define SLA2, SLA2.
We have an online question from Ricky. Do you think it is acceptable that we have to expose internal details like locking outside of a module because export is a visibility modifier?
I don't know.
There you heard it. He does not know. Anybody else with a question?
How do you use const correctly? Because as soon as you try to complicate things with ranges or stacks of structs, you get into a load of pain. So,
well, if you get into pain, you know, the old joke applies. Doctor, doctor, it hurts when I do this. Don't do that then. if it's causing you pain, don't do it. I mean, think about if there's a better way of doing it, and if there isn't, then do that instead. You know, go about doing your job and don't worry about it too much.
Follow up on the same question. So I call a third-party library that I don't own. They don't use const. What do I do?
Then, unfortunately, you can't. But that's the reason why I said keep using const in your declarations. Is something I actually forgot to mention is if you keep doing that in unit tests, you have to for your own code, because otherwise it won't work with const objects. So if you keep using them, you have to actually add const at the end of the member functions. So, but of course, if you have a dependency that doesn't, what are you going to do?
Just as a word of warning to those who are actually trying this, if you try to declare your types as const, or if it's like for your structs, for instance, or you declare them as immutable, about half of standard algorithm breaks.
I would say to not declare the types themselves as const, because I don't think you should limit what your clients should do with your code. If they want to use a mutable version of it, why shouldn't they?
All right, let's
you
do
can't
one more
anticipate, you know, what they're going to need to do. So,
on your wrapping main and then in the run, would you also pass in stdout and error through as well, so that your streams you're never writing directly to stdout, so you can capture them in text?
I would not do that. I think, well, first of all, I think things like printf and writeln should not be used ever, and the reason for that is global state. What you should be doing is passing some object, or a file even if you really want to, but normally what I do is I do a template thing, because I don't want to constrain it to be a file object. It could be something else, and that would be what you do .writeln to. That way, you can pass std_error and stdout in the wrapped main, so that was uses in the real implementation. But then when you're testing, you can just append strings and assert that the output was this.
What I've been drifting towards over time to address that is to pass in a sync parameter. So all your messages go there, and that means the caller decides what to do with it. Can throw it away, can write it to a file, can write it to stdout, could write it to stderr. It's entirely up to the caller. The engine itself shouldn't need to care where those strings go.
All right, then we're done here. So thank you for the rant.